Welcome to HVAC-Engineering-Techie. This is the channel where we talk all things HVAC. We talk about engineering design, we talk about construction, we talk about equipment, we talk about systems, we talk about test and balance extensively, we talk about controls, and we talk about systems performance. So we do all that in an effort to give you the education you will need to advance your career. So basically today we're going to talk about basic math for technicians. I realize that's a boring subject, but you really need a good foundation of this math to be able to advance in your career. So if you're really good at math, you probably don't even need to take this video, but if you had trouble with this in school or it's been a long time and you need to brush up, then this video is for you. So before we get started, I'd like to ask a big favor. Would you please hit the subscribe and the like button down below? It's absolutely free. It costs you nothing. I will never bug you. It's just that Google used those to test how well these videos are viewed. And that will really help me out. So I'd really appreciate it. So let's get started and good luck. All right. So now let's talk about decimal equivalents. The decimal equivalent is the decimal equivalent of a fraction. Now, it's easy to turn a fraction into a decimal, basically because you just have to divide one by the other. So if you have 3/8 and you want to turn that into a decimal, you simply divide 3 by 8, and that gives you 0.375. You want to turn 9/16 and you divide 9 by 16, it equals 0.5625. So it's really easy to do on your calculator, makes it easy to do. And the reason we do this is because to multiply 3/8 times 9/16 can get cumbersome in fractions, for which you have to, several rules you have to follow. The same with add and subtraction. But if you turn them into decimals, it's super easy. So then you just multiply the decimals and you get the answer. So if you have 3/8 divided by 1/4, turn them into decimals and divide it on your calculator, you get 1.5. So it makes it much easier, and this is really easy to do since everyone carries a calculator nowadays. Assume you all have a smartphone, and on that smartphone is a calculator that you can use. A decimal is the ratio of the numerator to the denominator. To use as a percentage, multiply 100. So let's say a 3/8 is actually a ratio of 0.375 of 8, which equals a ratio of 37.5. So if you're trying to get a percent, you just take your decimal equivalent and multiply it by 100, and you get your ratio. So let's say a supply grill has 200 CFM, and the other supply grill in the room has 400 CFM. So what is the percentage ratio of the first grill to the second grill? Well, it's 200 divided by 400 equals 2/4. We can reduce that by 100. Or you reduce it further, it's 1/2, which equals 0.5. If you divide 1 by 2, it gets 0.5. Multiply that by 100, you get 50%. So we know that grill 1 is flowing 50% of grill 2. That's easy to do when they're nice, easy numbers. It gets a little more cumbersome if you're doing more. Now, what is the first grill flowing 50% as much as the second grill? What is the ratio of the first grill to the total of both grills? So then that would be 200 over 600, which equals 2/6 or 1/3, which equals 0.3333. And you multiply that times 100 to get 33.3%. So that's how ratios work. And ratios, we use a lot of ratios. It's easy to move between one capacity and another by using a simple ratio. Okay, decimals to fractions. Now going back the other way is a lot harder. There's no easy way to do this. So you just have to sort of suffer through this to get it. To turn a decimal into a fraction, divide the decimal by 1, then multiply both the numerator and the denominator by either 10, 100, 1,000, or more, depending on how many characters there are to the right of the decimal. Because what we need to do is we need to get it to a whole number. So we make it bigger numbers to do that. So example. So if we have 0.52, so you take 0.52 and divide it by 1. And because it has 2 decimal places, 1, 2, we're going to multiply it times 100. So then we get this divided by 100 and 1 times 100. So it's 52 divided by 100 equals 13/25. Now we need to reduce that fraction, and this is the hard part. Doing this is easy. Reducing the fraction gets to be the irritating part. So what you do is you find a number that you can divide both the numerator and the denominator by that, and they both become whole numbers. You can't do 3.5 over 4.6. That doesn't work. It needs to be whole numbers. So in this case, it's divided by 4. Okay, example 2, 0.5625 would equal 0.5625 divided by 1, and then we're going to take and multiply it times 10,000 because we have 4 decimal places. So then it's going to be this time 10,000 divided by 1 times 10,000, which equals 5625 divided by 10,000. Now to reduce this is not obvious. Whereas this one up here, okay, easy to do. This one here is, you got to think about it a little bit. So what you do is you take the numerator and you divide by a bunch of numbers to give you whole numbers. Now how do you know which ones to do? Well, you don't. So you take your calculator and you start trying. Well, 1 was easy, right? Because 1 divided by itself is always the same number. 2 doesn't work. It's not a whole number. So you go to 3. Well, look, that's a whole number. Good. So you go to 4. That doesn't work. Go to 5. Oh, that one worked. And you keep going until you get whole numbers. And you can sell it between 9 and 75. There aren't any. So you can tell there's a long stretch here to get to. So then you go to the denominator and you do the same thing. Well, it's a nice whole number. 10,000. So basically it makes it easy. 1 divided by itself is 10,000. Divided by 2 is 5,000. Divided by 4 is 2,500. 5 is 2,000. 8 is 1,250. 10 is 1,000. 16 is 625. Well, wait a minute. That's the same number we have up here. So we really don't need to go any further, because once we find a whole number that we can divide both the top and bottom by and get a whole number, we've got our solution. So what that means then is we take our 9/16. If you take 5625 over 10,000 and you divide the top, by 625, you get 9. And if you take the bottom and divide it by 625, you get 16. So that reduces to 9/16. Now, most of you knew that 0.5625 is 9/16 by working in the field. But if it's a big number and you don't know, you have to go through this process. Now, there are apps to help you with this on your phone. The problem is they don't work very well. I have not found one that will consecutively do very large ratios or fractions. So I think for right now, if you got to convert, you're kind of stuck with this process. Now, in practicality in the field, you get used to doing it. Well, that's almost ½ inch, so that's close enough. If you're framing lumber, a millimeter is not significant. If you're machining a piece of steel, it's very significant. So then you've got to be more accurate with these things. Algebraic equations. Okay, this is where we start getting to where we really need to be. An equation is a mathematical statement that two things are equal as indicated by the equal sign. So it just simply means that when you see an equal sign, it means that whatever's on either side is exactly equal. And that fact is what allows us to be able to solve these equations. As an example, the airflow of a duct is equal to the area of the duct multiplied by the velocity of the duct. That's the standard equation. Q equals A times V, where Q is the flow in CFM, A is the area in square feet, and V is the velocity in feet per minute. So if you know the CFM and wanted to find the air velocity in a duct, you would need to rearrange this equation because you can't work that out that way. So what you would do is you'd take and get A out of this side of the equation because you want velocity by itself. So you divide everything by A. So you divide Q by A, and you divide A over times V by A. And then what happens is these two cancel each other out, and you end up with Q over A, which equals V. So that's how you find velocity, and that's how you rearrange an equation. Now this one is really simple, but when the equations get to be difficult, this gets to be difficult to do also. Let's talk about powers. Powers is means a number of times the base number is multiplied by itself to get the product. So this says 3 to the second power equals 9. What this means is you take this base number, 3, and you multiply it times itself the number of times specified. So 3 times 3 equals 9. So that's what the power means. So standard numbers means that, if you take 3 by 3, that's 9. You take 3 squared, that's 9. Or you take 3 to the second power, that's all 9. They're all the same. They're just different ways to express the same thing. So cube numbers is the same thing, except it's a power of 3. So instead of 2 up here, it's a 3. So 3 to the third power equals 27. So it's 3 times 3 times 3. Or in this case, it's 3 to the third power, or 3 in parentheses to the third power, all means the same thing. Now, luckily on your calculator, if you take your calculator, and at least on my iPhone, and I'm sure it's on the other phones too, when you hold it vertically, you get a regular calculator that adds, subtracts, divides, and multiplies. But when you turn it on its side, you get a scientific calculator that has all these functions. And on that calculator is x squared, x cubed, and xy. And xy means any number. So it can be to any power. You don't have to do just squares and cubes. You could do 0.2. You could do 142. You could do any number you ever want to do that on your calculator. Now, the way you do this, these are easy. You just push that function on your calculator to get the answer. This one, you put in x first. You put in x first, and then you hit that key, the x, whatever, xy key, and then you put in the y number and then hit equals. So here's my calculator in its standard position. And when you move it over, you get all these functions. So if I take the number 12, and then I push the x square key, then I get the answer, which is 144. 12 squared, 12 times 12 is 144. So if I take 12 and I hit the the cubed key, then I get 1728, because that's 12 times 12 times 12. So then if I take 12 times this xy key, and then I put in 0.5 for y, and then I hit the equals key, I get that number, which is 3.46 and a bunch of decimals. So that's how you do those functions. The calculator makes it extremely easy to do. Okay, now we're going to talk about roots. Now, roots are exactly the opposite of a power. So the root of a number in a math is a number that, when multiplied by itself, produces the original number. So let's see, this is a square root here. So this is a root function symbol. And what it means is you're going to take, and this is the root, so we're going to take a number that will equal 3. So, and what we're trying to find is the number that multiplied by itself 2 times equals that number. So it's exactly the opposite of the power that we did before. Now also, there's square root, cubed root, and a y root. So you have exactly the same thing, but in the opposite, in the root function instead of a power function. So the same thing, when you do this on your calculator, you enter the x number first, and then push the xy, then enter the y number, and then it equals. So here we go again. If we have 12 and we push the square root, we get 3.46, which is the square root of 12. If you push 12 and push the cube root, you get 2.289 a big number. So that's how you do the square roots and the cube roots on your calculator. Now, to do a special root, if you do 12 and input the y root function, and then put in 0.5 again, and then hit equals, you get 144, which is the when you take 0.5 to the root, and that's the answer. So these, again, are easy to do on your calculator. As long as you got your phone handy, these are easy to do. Okay, scientific notation is when you have a very, very large number and you need to reduce the number to fit in your calculator or fit in whatever you're doing. And so they come up with scientific notation. It's just a way to make a very large number or a very, very small number to be in a whole number, so you can easily deal with it. So here's how it works. For a large number, such as 3,640,000,000, that's a big, big number. It's hard to type all those zeros in. So to change that, what they do is they move the decimal place. So what happens is we're over here and we want to move this decimal place till we get a whole number. Wow, a whole number with a significant number. So basically we move that decimal place over here to there, we get 3.64, and then we put a symbol, -10, to the ninth. And the reason it's ninth is we count the decimal places you moved. 1, 2, 3, 4, 5, 6, 7, 8, 9. Move that decimal place to there. And that's how this symbol is written. Now that's not a minus sign, and that's not actually a power. It's just a symbol that tells you this is how many places we've moved this decimal place. Now it's the same thing with a small number. You want to do the same thing. You want to get it to the number becomes a negative power. So this represents this 10 to the -4. Now here we'll do it again. So we have this number 0.000246. So we want to remove it so we have at least one decimal place. So we move it 1, 2, 3, 4. We move it 4 times. So then it becomes -10 to the -4. And -4 meant that we moved it to the right 4 places. This +9 says that we moved it to the left 9 places. So basically when you get a number like 3.64 and it's got that symbol, you know it's really a big number because you're moving this to the left. And that's what scientific notation is. Now sometimes on your calculator, when it overflows, it'll give you this, the number will actually be in scientific notation. And then you can actually change it to a real number by using this procedure. Okay, parameters of a circle. We use a circle, comes up a lot in our calculations as technicians. So we need to get a good grip on what the circle is. So on a circle, the circumference is the area of the circle, of the round the circle. The diameter is the dimension of the width of the circle, and the radius is from the center point to the edge of the circle. Those are the 3 pieces of a circle that we use a lot. And here's the standard formulas. The circumference, which is the outside of the circle, equals pi times d, the diameter. So you take the diameter, multiply it times pi, and you know how many feet are in the outside of the circle. And for the area, it's a equals pi times r squared. So you take r and square it and multiply it times pi, and you get the area within the circle. Now pi is a constant number. It's and it's always the same. It doesn't matter how big or how small the circle is. Pi is always the same number because it is the ratio of the circumference divided by the diameter of a circle. And since a circle is always round, it's always the same number. So it doesn't matter if it's 144 foot diameter, pi is still 3.1416. So if you take and divide the circumference by diameter, you'll get that number every time, no matter what these numbers are. Now, this number is really 3.1415 and a whole bunch of decimals, like forever. So the HVAC communities basically said 1416 is good enough for almost every calculation we want to do. Now, unless you're doing something extremely accurate, which we would never do in HVAC, then you might need some more decimal places. But basically, this is the one we're going to use. Okay, so let's take an example. Find the area of a 24-inch duct. So if we have an area, it's pi times r squared, and that would equal, area is 3.1516 times 1 foot squared. So that's pi times 1 squared equals, basically 1 times 1 is 1, so it's still the value of pi. So for a 24-inch duct, the area is equal to pi, which is kind of a trick, but it does. So find the surface area of a 36-inch duct that's 100 foot long. Well, first of all, we find the circumference of a 36-inch duct, and then we multiply it times the length, 100 feet. So again, C equals 3.156 times 3 feet, the diameter, equals 9.45. So this circle, a 3-foot circle, has 9.45 feet circumference. Multiply that times 100, we get 945.5 square feet. So you use something like this if you're trying to figure out how much insulation you need on a duct, or if you're doing a duct test and you need to know the surface area of the duct. So that's the standard circle calculation. All right, let's get into the meat of this deal. Let's talk about, okay, CFM2. Here's a standard equation, a fan equation that we use a lot to find different CFMs. It says CFM2 equals CFM1 times RPM2 over RPM1. So if we know the airflows and want to find the RPM, rearrange this equation for RPM2. So if we want to find that number, okay, you got to change this formula for that. So the first thing you would do is change the CFMs from one side to the other. So we take CFM1 and move it to the other side. To do that, we divide both sides by CFM1. These two cancel out. That gives us equals CFM2 over CF1 equals RPM2 over RPM1. Say, well, that didn't get us anywhere. We're still in an equation we can't deal with. Well, in a little while, I'm going to tell you how to use this formula. You don't have to go any further. But right now, we'll go further to tell you how now you get RPM to the other side. So we need RPM1. What happens, we'll take, the equation becomes CFM2 divided by CF1 from this equation times RPM1 over RPM2 over RPM times RPM1. Now what happens is these RPM1s actually cancel each other out, which equals RPM2 equals RPM1 times CFM2 over CFM1. And there's the one we were trying to find out. What does RPM2 be? So that's how you rearrange these equations. Now these look pretty simple like this, but if you get in a starting equation that have lots of roots or powers in it, and oh man, they can get complicated because there's a lot of rules you have to follow when dividing by a square root or something like that. So this way, what I'm going to show you in a little bit here, this other areas, you don't have to worry about all those rules. So that's why I prefer the simple method. I'm not brainy enough to figure out all this all the time. So it's called cross multiplication. So what we're going to do, so if we have this formula, my favorite form of the formula, which is two things on each side. Let's say we have a system that has 500 CFM and an RPM 150. That's both the ones. And we want to raise it to 600 CFM. So what RPM do we need to be able to raise it to 600? Well, it's really simple. You multiply this times this, and then multiply that times that, and then divide out the number. So basically it's 600 times 150 equals 500 times RPM2. Well, that equals, when you multiply those, that equals 90,000 equals 500 times RPM2. And then you just simply divide the other. It's easy to see that what you need to do is divide this by that to get that. But if you want, you can go through the same process of moving it over. 500 divided by 500 and 500 divided by 90,000. These two cancel out and you get the same thing. But it's just easier to remember that, okay, I got a number, I need to divide it by that to get rid of it on that side. And that means 180 RPM. So that's what our RPM2 is going to be, 180. Now, you can always check these answers to make sure they're reasonable. Because when you make a mistake, and what I mean by making a mistake is if you have these wrong. So instead of this formula, you have RPM2 on the bottom and RPM1 on top, or vice versa. This number could come out to be 90 RPM. You go, well, you think about it. We're increasing the CFM, so we need to increase the RPM. So originally we had 150, now we have 180. Okay, this looks reasonable. So it's always easy to check your answer for reasonability. This is the way I use this on every equation I ever do from a fan law or pump law. It's just so much easier. All right, that's basically it. So it was a short system, and I hope it was beneficial. See you on the next one.